Hello students, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our series on triangles for class 10 student. Note that this complete series is as per the latest updated syllabus, and in this complete series we will cover all these chapters using the power of animation and the visual tool to make the tough concept easier for you. In this lecture we will cover the BPT theorem, that is basic proportionality theorem, and the link to all the lectures is given in the description. Check it out. And students, one important thing, do not forget to download the PDF of the concept and formula list. The link is given in the description. That will be really helpful to solve the question and also brush up the concept whenever you are having the exam or whenever you need so. So without taking any further time, let's start with this lecture. Best of luck. Hello, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our lecture on triangles, in which we will cover the BPT theorem, in which we will cover the concept of BPT. We will cover the concept in very detail. We will also cover the BPT theorem, the converse of the theorem, and also we will take down questions related to BPT theorem for your understanding. So let's start with the lecture. BPT theorem, which is known as basic proportionality theorem. This is very important concept related to triangle. Firstly, we will understand the BPT theorem or the concept of BPT. Then only we will move to the proof of the theorem. The proof is very simple, but before that, understanding of the concept is very important. Let's understand the concept. Suppose we are having a triangle ABC. The three sides are AB, BC and AC. If we take a line segment parallel to BC, here this is the line segment DE. The point D is on the side AB and the point E is on the side AC. Here it is very important that the line segment DE is parallel to BC. Here point D is dividing the complete side AB into two parts, AD and DB. Similarly, the point E is dividing the line segment AC into two parts, AE and EC. The concept is that whenever the line DE and BC both are parallel to each other, then these two parts, that is AD upon DB and AE upon EC, will be equal to each other. This is very important concept. When the line segment DE and BC are parallel to each other, then their respective ratio of the sides will be equal to each other, that is AD upon DB will be equal to AE upon EC. So this is the BPT theorem. Whatever triangle you take, if this DE and BC are parallel to each other, the ratio of AD upon DB will be equal to AE upon EC. Whatever triangle you will take, all these ratios will be equal to each other. Rest, it is depending upon your imagination. You can rotate the triangle also, or you can take the other side also. For example, if we replace the side BC with AC. Now let's take the line DE on the side AB and BC. Are you getting this concept? Here we have just moved the line segment parallel to AC. Initially it was parallel to BC, the DE is parallel to BC. Now for further clarity, we have taken the line segment DE which is parallel to AC. Here BD upon DA will be equal to BE upon EC. This is the BPT theorem. Got it? Here DE is parallel to AC. So the respective ratio on which the point D and E lies on the respective side, that ratio will be equal. If you take the line segment here, then these ratios will be equal. You can rotate the triangle, you can stretch the triangle, you can do anything, just these ratios will be equal. Rest is depending on your imagination, how better you can visualize the picture. In the questions, this picture may be slightly tricky, but overall the concept will remain the same. Sometimes the question framer may miss some of the part, or he or she may give some of the additional component. Just you have to find the two lines which are parallel to each other and try to draw the triangle around the two parallel lines. If you have understood the concept that I have told in the last 4 to 5 minutes, then you can solve any questions related to the BPT theorem. Got it? When we move to the question, you will further understand how to identify these parallel lines and how to extract the triangle around the parallel line. That we will do when we move to the questions. So this is the basics of the BPT theorem. Let's analyze this concept of BPT using some construction experiment, just for your better understanding of the concept. Let's take a triangle. Random triangle you can draw on your notebook. If you draw, it will be very good, and this concept will directly go to your subconscious mind. My advice is that just take out your notebook, draw with me. Pause the video and you can draw. This will be really helpful to you. Just take a random triangle, any triangle, whatever you like. Here I have taken this weird looking triangle. Let's measure the two sides of the triangle, AB and AC. For my case, AB is coming out to be 4 centimeter and AC is coming out to be 10.2 centimeter. Now we have to draw the line segment which is parallel to BC. Let's draw it. You can draw anywhere, on the upper side, on the lower side, anywhere in which you are feeling comfortable. Let's take the point as D and this point as E. Let's measure AD and DB. For my case, AD is 2 and DB is also 2. Let's see what is AE and EC. For my case, AE is 5.1, something like that, and EC is also 5.1. So let's take the ratio of AD upon DB and similarly AE upon EC. AD upon DB will be 2 upon 2, which is 1, and AE upon EC 5.1 upon 5.1, which is basically 1. So I can say the ratio of AD upon DB is equal to AE upon EC. Share your result in the comment section. If you do this small experiment, very small experiment you can do on your notebook, then this concept you will never forget and you will be able to solve any question related to the BPT concept. Okay? Share your result in the comment section. Both of these ratios will be same. Any weird triangle, any rotated triangle, anything you can take, but this result will not change. So students, we have done with the concept of BPT. Let's move to the next step and let's do the proof of this concept or the BPT theorem, which is theorem 6.1 in the NCERT book. This is as per the latest syllabus. Before moving to the theorem, one important concept is used in the theorem based on which you can solve this theorem very easily. The concept is area of the triangle. We know area of the triangle is equal to half into base into height. This is the formula you must be knowing. Base, you can take any side as base and the perpendicular will be with respect to that base. For example, we are taking the base as BC, then what will be the perpendicular? Perpendicular will be AD. Here AD and BC are perpendicular to each other, so our formula will be half into BC into AD. Similarly, we can take the base as AC, then the perpendicular will be AE. If we take the base as AB, then the perpendicular will be FC. Perpendicular will change as per the base we take for calculating the area of the triangle ABC. Got it? Area by using all these three formulas will be same, which is basically half into base into height. The additional concept is that if we take slightly oblique type of triangle, this is the slightly twisted type of triangle. Here we are having the triangle ABC. If we take the base as BC, what will be the perpendicular? Perpendicular will be the line drawn from A toward the line BC, which is basically perpendicular to BC. Here in this case, if we draw the line AD, it will be outside the triangle ABC. Note that this is important concept. If you know already, this is very good. But if you do not know, just pay attention. Perpendicular can be outside the triangle ABC. Here we are having the triangle ABC. We have to draw a line segment from A to the line BC, which should be perpendicular to BC. Here this line is perpendicular to BC and we can move it on the BC outside and inside, and it should start from the point A. So here AD is perpendicular to BC. So the formula will be half into BC into AD. Got it? The perpendicular can be outside of the triangle ABC. We can move the triangle to other side. We can slightly twist that. AD will move to other side. Got it? Just an additional concept which will be helpful. If we form a new triangle here the triangle or previous triangle is ABC, this is AD, and new triangle is ACE. So this is a new triangle we have just taken for the experimental purpose. Here area of the triangle ABC is half into BC into AD. Got it? What will be the area of this triangle ACE? It will be half into base into height. If we take the base as CE, then the area will be half into CE into AD. For this triangle also, the perpendicular will be AD. So both of these triangles are sharing the common perpendicular. Area of triangle ABC is half into BC into AD. Area of triangle ACE is half into CE into AD. Got it? So we got one new concept, that is two triangles can share the common altitude or the perpendicular or the height. So if you know this concept, the concept of area of the triangle, the concept of base and concept of perpendicular, you can solve this theorem on your fingertips. Okay. So let's move to the theorem. I could have directly started with the theorem, just explaining the various triangle, lines, etc. But that will not be the effective method. Effective method is building the base, then on the base, growing the complete building. Okay. So let's take the theorem 6.1. That is the BPT theorem. The theorem is, if a line is drawn parallel to the side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Let's observe the wording. For that, let's take the triangle ABC and also draw the line segment DE, which is parallel to BC, the same we have done previously. So the theorem is saying, if a line is drawn parallel to one side of a triangle, so here we have drawn the line segment DE, which is parallel to BC, that is one side of a triangle, to intersect the other two sides in a distinct point. So it is intersecting with side AB and AC at point D and E respectively. The other two sides are divided in the same ratio. Other two sides means the side AB and AC will be divided into the same ratio. That is, ratio of AD upon DB will be equal to AE upon EC. So the same concept we have just learned. So this is a theorem and this is a wording. Got it? Let's prove that AD upon DB will be equal to AE upon EC if DE is parallel to BC. Note that it is given DE is parallel to BC. If these two lines are not parallel, then the ratio will not be equal. Let's move further. Let's join the point D and C and also join the point B and E to form the line segment DC and the line segment BE. Here, are you able to observe the various triangle? We are having the triangle ABC, which is the main triangle. We are also having the triangle ADE, this smaller triangle. And we are also having the triangle BDE, this triangle, and also the triangle DEC. So basically we are having the several triangles inside this big triangle. Based on this several triangle, we will find the area and we will equate. Let's see how to proceed. Here, what will be the area of the triangle ADE? That will be half into base into height. Let's draw the height. If we take the base as AD, what will be the height or the perpendicular? The perpendicular will be EN. This is EN, which is perpendicular to AD. That will be the height of this triangle if we are taking the base as AD. So the area of this triangle will be half into AD into EN. Simple, got it? Nothing special. We can also calculate the same area of this triangle using the base as AE. If we take the base as AE, what will be the perpendicular or the height? The height will be DM. This DM is perpendicular to AE. So we got the area of the same triangle ADE also as half into AE into DM. So we have calculated the area of the triangle ADE in the two way using the two different bases. Got it? Let's find the area of the triangle BDE and also the area of the triangle DEC. So let's highlight this triangle BDE. So if we take the base as BD, what will be the perpendicular or the height of this triangle? The height will be line drawn from the point E toward the base BD. So here EN will be the height of this triangle. The concept we have just discussed, the height or the perpendicular can be outside the triangle. For this case, this EN or perpendicular or the height is outside this triangle. So area of this triangle will be half into dB into EN. Got it? Let's find the area of the triangle DEC. If we take the base as EC, what will be the height? The height will be DM. Here also the height DM is outside of this triangle DEC. So the area of this triangle will be half into EC into DM. Any confusion? We have just simply used the formula of the area of the triangle. Height is outside the triangle, which we have just discussed how the height can be outside the triangle. So building the base is very important. If you do not know the concept that height can be outside, you will be confused. So let's move further and let's find the ratio of area of the triangle ADE upon area of the triangle BDE. That will be AD upon DB. Okay, AD upon DB. We got one side of the equation that we have to prove. Second, let's find the ratio of area of the triangle ADE upon area of the triangle DEC. We got the ratio as AE upon EC. Got it? Here we have to prove AD upon DB is equal to AE upon EC. Basically, we have to prove this is equal to this. So let's see, can we do so? Here ADE is common in both. If we somehow prove area of triangle BDE is equal to area of the triangle DEC, then we can say both of this equation or AD upon DB is equal to AE upon EC and our theorem can be proved. So can we say area of these two triangles are equal to each other? Observe. Take some time, pause the video and observe. Is area of both of this triangle are equal to each other? Use the formula of area of the triangle and try it. Okay, coming back. Let's find the area of the triangle BDE. This triangle. If we take the base as DE, what will be the perpendicular? This will be the perpendicular. Okay, I am not giving the name. We have already given various nomenclature. Just this is the perpendicular or this is the height. I am taking this as H. So area of this triangle will be half into DE into height, that is H. Similarly, what will be the area of this triangle DEC? It will be half into DE into H. DE is the base and H is the height. For both of this triangle, the height will be same. Here DE and BC are parallel to each other. Two lines are parallel means this gap will remain the same. This can move or slide across this line segment. This will be same. Are you understanding? Both the lines are parallel to each other, so this distance will not change. Suppose if DE is slightly twisted, then this height will not be same. Here both of these line segments are parallel to each other, so the height will be same for both the triangle. So we got area of both of this triangle as equal or same. So we can equate both of this equation and we can say AD upon DB is equal to AE upon EC. So that is a proof of the theorem, proof of the BPT theorem. Very simple, very easy. What we have done, we have just used the concept of area of the triangle. Firstly, we have calculated area of this triangle ADE using the base as AD and AE. Then we have calculated area of the triangle BDE using the height as EN and also area of the triangle DEC using the height as DM. And in the end, we have equated area of both of this triangle and observe that area of both of this triangle are equal to each other. Okay, very simple. So we got the proof of this theorem. Let's move further and let's do the converse of this theorem. That is very simple. Converse means opposite of the theorem, that is theorem 6.2. The theorem 1, that is 6.1 BPT theorem, is saying if two lines are parallel, then these ratios will be equal. Now converse is that if these ratios are equal, then these lines will be parallel to each other. Okay, that is the converse. Let's do it. We will do very fast. It is very simple. Here we have to prove DE is parallel to BC. For the time being, we will say DE is not parallel to BC. So here both of the line segment we are assuming as not parallel to each other, and in the end we will prove both of these line segment are parallel to each other. Now let's take a new line segment DE dash, and we are saying this DE dash is parallel to BC. We are assuming that. So if these two line segments are parallel to each other, so we can apply the BPT theorem, and we can say AD upon DB will be equal to AE dash upon E dash C. We have simply applied the BPT theorem. DE dash is parallel to BC, so we can say the ratio of the sides will be equal to each other. Let's equate both of this equation. We got AE upon EC is equal to AE dash upon E dash C. Let's add 1 to left hand side and right hand side, that is on both sides of the equation. We got AE plus EC will be the complete length AC, and AE dash plus E dash C will be equal to again the complete length AC. We got AC upon EC is equal to AC upon E dash C. On solving, we got EC is equal to E dash C. So basically we are saying this line segment EC is equal to this line segment E dash C. Is this possible by visually looking? No, this is not possible. EC is not same as E dash C, but we have proved both of this equal. That can only be possible when E and E dash are basically the same point. So this E and E dash are basically matching with each other. That is, the line segment DE is basically the line segment DE dash. And we have assumed the line segment DE dash as parallel to BC. So basically DE will also be parallel to BC. So that is the proof of this theorem. Okay. So students, we have done with this lecture. Hope you have enjoyed the lecture created using the power of visualization, our unique way of teaching. And do not forget to download the formula and the concept list. The link is given in the description. And also this series or this lecture is part of the complete series on the triangle. The link to all other videos are given in the description. Also check it out. So thank you very much for being with CREATA classes. Have a great day and meet you in the next lecture. Bye for now.